Okay guys, first thing I want you to do is write your name on your handout. We're going to go through and take some notes about functions and relations. We've been studying them this week, and I want to make sure that you have these vocabulary words identified. A relation can be represented by a set of ordered pairs. Ordered pairs would be like 3, 5, 6, 2, 8, 1. Those would be ordered pairs in a relation. They would form a relation. The domain is the set of all x values. The range is the set of all y values. The independent variable is the same as the x values and the domain. The dependent variable is the same as all the y values and the range. A relation is a function if for each x value there is exactly one y value. That's very important to know the difference between a function and a relation. A relation is any set of ordered pairs. It doesn't matter. A function has exactly one x value. It has exactly one y value for each x value. Each value in the domain of a function is called an element, and the corresponding value for the range is called an element. These last two are not used as much in Algebra 1 as they are in upper level math courses. Identify the domain and the range of each relation. So to identify the domain, we are going to look at the x values. So that would be -2, 0, 4, and -2 is repeated again. Now when that happens, you don't have to write it twice. You just write it once, and you put the little squiggle lines and separate it with comma. The y values make up the range, and that would be 0, 3, -7, and -1. Now pause the video and find the domain and range for number 2. Question 3 says, determine whether the relation is a function. Explain why or why not. Well, for it to be a function, no x value can be repeated. So as we look across, we look for these x values and we see that 0 is used twice. That indicates it is not a function. It is still a relation, but it is not a function. Pause the video and answer questions 4 and 5. When given a graph or a picture of a relation and ask if it is a function, the vertical line test is used. This test helps you know if a relation is a function by looking to see if any vertical line drawn does not intersect the graph at one or more of the points. In other words, on the graph, each x value is paired with only one y value. So let's look at the examples they have here. Number 6, if you take a vertical line like this pen and you slide it across the graph, it only touches one dot at a time. So it passes the vertical line test. It is a function. Let's look at number 7. If you take a pencil and you slide it across, you get right here, it's going to touch this one and this one at the same time. See, the x value is paired with a y value that's positive and a y value that's negative. When the x value is paired with two y values, the dots line up vertically. They stack, which causes it to fail the vertical line test, and this one is not a function. Number 8, You just imagine sliding a pencil or a straight line across and it touches it twice, so it is not a function. Number 9, even though it's curvy, it does pass the function test, so yes, it is a function. Mapping diagrams and tables can be used to determine if a relation is a function. In a mapping diagram or a table, each x value will be paired with only one y value. A y value may be paired with more than one x, but it can't be the other way around. So determine whether the mapping diagram or the table represents a function and circle yes or no. Well, you want to focus on the input. These are where your x values are. This is your domain, your x values, your input. 1, 3, -2, 5. Each of these numbers is connected to only one number from the output or the range or the y values. So yes, this one's a function. Number 11, you see that number 3 has 2 arrows coming out of it at the same time. That means it's paired with 2 numbers. That causes it to fail as a function, so this one's no. Stop the video and answer questions 12 through 15. If a function is 1-to-1, when every element of the range corresponds to exactly one element of the domain, y equals f of x is a function if it passes the vertical is a line test. It is 1-to-1 if it passes both the vertical and the horizontal line tests. So now for 1-to-1 functions, you can't repeat x values or y values. So look at number 16. Do we have any x values repeated? No. Do we have any y values repeated? No. Is it 1-to-1? Yes, it is. So I want you to stop the video and I want you to answer the questions 17 through 21. I want to talk to you a minute about function notation. We're used to seeing equations that say y equal 2x plus 3. And we know what to do in order to fill out a table like this. We take -1, we put it in place of x, and we work the problem. 2 times -1 is -2. -2 plus 3 is 1. So we get our answer of 1. Then we use 0. 2 times 0 plus 3. 2 times 0 is 0. 0 plus 3 is 3. 2 times 1 plus 3. 2 plus 3 is 5. This is how we would fill out a function table for y equals 2x plus 3. Sometimes when they write functions, instead of using y, they use f of x. It really doesn't mean anything any different than y. I don't want you to think that it means f times x, because it doesn't. It just means a function using x as its variable, and then it gives you the operations to do. So you would handle this exactly the same way. If you use -1, you would write f of -1 equals 2 times -1 plus 3. There's really no math involved with this part. This is where you do the math problem. -2 plus 3, which is 1. Then you would use 0. F of 0 equals 2 times 0 plus 3. 0 plus 3 is 3. And then you would use 1. 2 times 1 plus 3. 2 plus 3 is 5. I wanted to show you the function notation side by side with just plain old y equals, so that you would see there is no difference between the two. So if you're given a function and they put a number in those parentheses, they're telling you that that's the number they want you to use in place of x. Let's try some of these. f of x is equal to 5x minus 1. I want you to find f of 3. That means you need to plug 3 in place of x and work the problem. 5 times 3 is 15. 15 minus 1 is 14. Now, pause the video and find f of 7, f of negative 1, and f of 0. And then you'll be done and you can go to